Let's practice sketching cumulative area so far, now for a linear function. Try to remember what the formula for cumulative area so far is for just a general little f function. So try to write that before I write that. Ready? So it's starting at a usually, going up to x, f of t dt. And is that f of x, f of a, f of t, f of something else? That's f of x. So let's look at what's going on here. So we're going to start integrating at a. I'm going to do another axis here and say a here. So this will be my antiderivative. This will be my cumulative area so far. Did I just let that slip? Oh, well. What's the big F at a itself? That would be the integral from a to a. That would be 0, right? What about the area, cumulative area starting at a, going over a little ways here? I can imagine drawing a box. I don't have to worry about whether it's a left box or a right box or a midpoint box. And really the box should be super duper skinny, but I'm just drawing it a little bit not super duper narrow just so it's easier to see. So if I moved over there, moved from A to over here, then I would add some positive area, right? So I would get some positive answer here. And then if I move the same distance over again, I'm going to be adding more positive area, and it's even more area than I added the first time. So when I put another dot here, I'm not going to say it's increasing at the same rate. It's going to be a larger vertical increase than it was from 0 to here. So I'm going to go over here and up even more. So can you see how that's not a straight line there? And then I'm going to say let's go over a little bit more, add another box. And then here I'm not going to just go on a straight line from these two dots out to here. It's going to be an even larger. So I went over and then I added some more area, and now I'm going over and I'm adding not just the same area but even more area. So no two of those are on the same line because I'm adding a larger and larger area box each time I go. Let's try going backwards a little bit. If I started at A and I went backwards a little bit, what's happening here? I'm adding a positive height box, but if I'm integrating from A, I'm integrating from A to something less than A, so I would actually be using a negative area. So that's a little tricky, huh? So I'd be starting at 0, adding an area that is negative because I'm moving backwards with a positive height. And that box is not as tall as that box, so it's not even going to be a straight line with that. It's going to be a little higher up than where you would guess if that was a straight line from those two dots. And then I'm going to try it again, do another box, and now I'm adding again something with positive height and negative width. So it's going to be not even as low as a linear projection from there would be. And now life gets really fun. So from here to there, that box is basically 0 height. So the new dot here would be the same height as that. And now it's even more fun. This next box from here to there has a negative height, and we're integrating backwards from A, so its area is positive. Woohoo! It's a double negative area, so it's a positive area. So as I add that on to what I've had so far, it's actually going to start increasing. Now here it's going to end up above the x-axis just because of the way I'm drawing things, but there's no actual guarantee that it would end, that one box would put us back into positive territory. It depends on the steepness of the line and everything. And then I'd add another box, and again I'm going backwards, so I have negative width, and then I'm going up, so I have I'm going from the axis down, so I have negative height, so overall that's positive. And what shape am I kind of getting there? I mean, this is just by hand, so think about that. And maybe we'll go try that in Desmos. All right, I've got my graphical antiderivative sheet set up. I've got a nice linear function here, and I'm starting at a equals 5, so a little bit farther along the axis than where that x-intercept is, just like the drawing I drew. So let's start moving our upper end of integration, the b value. We're integrating from a to b, you could say, or from a to capital X or something, or even lowercase x. And as I move along, I'm adding area faster and faster because these boxes are getting taller and taller. And this purple curve here is my cumulative area so far. It started at 0 when I had a box of basically width 0. I mean, it being the purple curve. And the purple curve is increasing faster and faster as I go along that way. As I go backwards from my starting point at 5, now I'm adding up boxes with positive height and negative width. So my curve, my total area so far curve, is decreasing. And then once I get over here, now I have boxes of negative height and negative width. So my total area so far is increasing as we move to the left, which is kind of crazy to think about. But overall, what would you say the shape of that purple curve is? And where is its minimum? That's an interesting thing to think about. Let's go try something else on paper real quick. All right, let's try sketching the cumulative area so far curve for this original function. So if I started at A, I'd have a box of width 0. So my cumulative area so far would just be 0. Then if I go to the right and add a box, again, not really caring about whether we're doing left, right, or midpoint, I would add a box of some area. So I'm just going to choose a value there. And then the next box I do has less area, so this function here will increase still, because that's a positive area, but it won't increase as quickly as it did there. So if that's up a centimeter, let's say I go over and then I'll go up something less than a centimeter. And then the next box here, well, we could say that's a box of height 0 maybe. And then I would be adding a box of some width and height 0, so I'd stay at the same x value. And then the next box would be something like that. It would have positive width and negative height, and so that would be adding a negative amount of area. It looks like it's slightly less tall than that one was, so so big F will decrease slightly less there. And then the next box I'm adding will be taller, so it'll have more negative area, so this will decrease even faster. And you can probably guess what it's going to do there. Let's think about going back this way. If I add a box from A backward a little bit, that's going to be a positive height, negative width box. And so I'll be subtracting from this current value, and it's even more than the box to its right was, so it's going to be an even stronger decrease. And then the next one even more, etc. All right, so those are good ways of sketching the cumulative area so far curve by hand.